Okay, good morning, everybody. So for today's lesson, actually, we already started in the second chapter. That is kinematics. Okay, it's about study of movement. Okay, and we start with linear motion. Okay, so what is linear motion? Okay, what is learning objective first? You should be able to derive and use equation of motion with constant acceleration and sketch and use graph of displacement time, velocity time, and acceleration time for the motion with constant acceleration. So linear motion is a motion that is an object that is moving along a straight line. So this is a linear motion and this is non-linear motion. Okay. So if you remember in form 4, okay, you learn that is what is the distance. Distance is the length, okay, of the path irreversible of direction of motion. Okay, and what is displacement? Displacement is the distance, okay, from initial position to its final position. So if the car is moving up and down, we only count or we only see where is the initial position and where is the final position. Okay, speed, k is a rate change of distance travel, and velocity is the change of displacement travel. So if the car is moving up and down in such a way in the diagram, so the speed is depends on the distance. So distance of the car is moving down and up like this. So we have to use the distance. This is the distance, and this side is the displacement. Okay. So for velocity, we are using displacement. Okay, means that speed is speed is distance over time, while displacement is is velocity is a displacement over time. Okay, the rate change of different travel. So what is average velocity? Is the whole thing over here. So v times t, v is the average. How much is the average of this? Let's say the average by this area on the graph is looks like this. Let's say it was if you make an average of the shape, it will look like this. So this one will be the average to whole motion. Instantaneous velocity is a rate change of this table at some at that instantaneous. Okay, so let's say we are talking about at this particular time. Okay, particular time. So what is a v at that particular time? If you have a t at this time, okay, let's say this is 4 second and this is 8 second. So what is a v at this particular time? It is not the average of the velocity at that point. Okay, that is for instantaneous velocity. For acceleration is a rate change of a velocity, how much the change of the velocity at that time, and instantaneous acceleration is a differential rate of the change of velocity. So let's say same method, same concept in the average velocity. So this whole thing, let's say you make a average of the shape. Okay, so this one will be the acceleration of the whole motion. Instantaneous is at that point. Let's say this point, what will be the acceleration? At this point, what will be the acceleration? And this point, what will be the acceleration? So it is at that certain time. Okay. So motion with constant acceleration. Okay, equation of motion with constant acceleration. A equals to v minus u over t. We start with that. Okay. Remember this derivation is in your syllabus, so you should memorize, and it can be asked in the exam. So a equals to v minus u over t. So if we take out the v, we have V as the equation title. We have V equals to U plus AT, and V average equals to U plus V divided by 2. Okay, and this is only can be happen in uniform acceleration. So if we have a graph, let's say we have a graph, this is a graph of V over T. So let's say we have like that. Okay, because acceleration is constant, so V average is U and V. So average of this our it will be like over here, half of the UV. Okay, so uniform acceleration only happens in uniform acceleration. S equals to U plus V over 2 times T. Okay, how this happen is we have a displacement, actually called displacement. Okay, is equals to average V average, okay, times with the total time taken T. Okay, there you have S equals to UV over 2 times T. Okay, so you take over here and you replace with VAV. And then we have S equals to U plus AT divided by 2 and times T. So if you do the operation of the max, you have 2U plus 2AT squared over 2, and you came up with S equals to UT plus 1 over 2 AT squared. And S equals to V plus U over 2, okay, and V minus U over A. So this is this one is came from V average, okay, S equals to V average times with T, where T is V minus U over A, right? It came from this point, this first equation. Okay, so VAV times T, so you do the multiplication and you have V square equals to U square plus 2AS. So those with the yellow font or the yellow writings are the ones who are the important formula. Okay, so remember V equals to U plus AT, S equals to UT plus 1 over 2 AT squared, and V square equals to U square plus 2AS. Golf club given an average of acceleration of 1500 meter per second for 0.02 seconds in the opposite direction to its initial velocity. Find the magnitude of the velocity of the ball after leaving the golf club. Okay, so we use the one of the equation of the constant acceleration. So A equals to V minus negative U. Okay, assuming that it's coming from negative because actually the ball came to the golf club, okay, and then going back in the opposite direction. So we can say that this is a positive and this is negative. So that's why we have negative over here. Okay, direction on the left is positive, direction on the right is negative. Okay, so 1500 equals to V plus 12 divided by 0.02. This is also time, divided by time, and then V equals to 18 meter per second in the opposite direction. Okay, so answer is 12 meter per second. Okay, next, a speeding bus is traveling at constant speed of 10 meter per second on a straight road. It passes a stationary car with immediately accelerate from rest with an acceleration of 2.5 meter per second. Calculate what times the car overtake the bus. So the situation is we have a bus is having a constant velocity, doesn't have any acceleration, and then it was moving in 10 meters per second, and it was passed by a car. I mean, the car was passed by the bus. Okay, so this is a car. It was stopped, and it wants to accelerate later after uh, it was passed by the bus. There is 2.5 meter per second acceleration. This is acceleration. This is velocity. So calculate the time it takes for the car to overtake the bus. So after they have the same, I mean, both of them have the same starting point. Okay, what time uh, the car will overtake the bus? Okay, so this one we need both of them. One is without any acceleration. One that is the bus. One is the car with the acceleration. So when we say that both of them are taking when the car overtakes the bus, okay, the text is the distance of the travel, both of them is same. It means that when the bus, let's say this is a bus and this is the car, when they goes at some point, both of them had the same distance traveled, so that you can say that that is the point where the car overtakes the bus. So you can say the bus, okay, we can say that x equals to ut, and it is 10t. Okay, right. For the car, because it was moving 10 meter per second, for the car, s equals to ut plus 1 over 2 at squared. Okay, and x equals to 0 plus 1 over 2. Okay, why 0? Because the car was stopped at the initial position. At squared equals to 1 over 2, 2.5 times t squared. So 10t equals to 1 over 2, 2.5 times t squared, and so t equals to 0.0 second. Okay, so it took 8 seconds for the car to overtake the bus. Okay, so actually what I can say that this is by the bus and this is by the car. Okay, so equal both of them. There you have t equals to 8.0 second. Okay, for the free fall, a body is said to experience a free fall if it falls under the action of gravity in vacuum. For position close to the surface of the earth, the acceleration of free fall or the acceleration due to gravity g is constant and is assumed to be 9.81 meter per second. So remember, in form 4 and form 5 you always round the number. Now in STPM, in SPM, you use 10 meter per second squared as the gravity acceleration. Now in STPM, it was much more detailed, that is 9.81 meter per second, because actually we are using 3 significant figures. Number 3, actually this is number 2, this is number 3. Since the acceleration due to gravity is constant during the free fall, the equation of constant acceleration can be used. Okay, so free fall happens only in vacuum. Okay, when any object that is falling in the vacuum, there you have a free fall. When a skydiver, okay, falls, it does not have a free fall, it's having a terminal velocity. What is a terminal velocity? When a person, let's say this is a ball, drops down from the airplane, when it drops down, it will be pulled by the wake. Right, it will pull by the wake. At some point, at some point, after it was falling down, there will be a friction or the drag of the air that's pushing the ball going upwards in this way. So there will be drag force. Okay, what happens is when you have a drag force, there will be a zero acceleration. So the weight was counted by the drag force. So what happened there, if you have somebody that is skydiver, so this is V, this is a T, so there will be S rates when it came up from the airplane. At some point there will be a static of constant of velocity, and this constant of velocity, this is what we call as this one we call as a terminal velocity. Okay, this is only happens when you have air or drag. Okay, just for a general knowledge, what is a terminal velocity term in physics. Okay, example, an object is projected vertically from the surface of the earth with initial velocity of 20 meter per second. Later, object fell back to the earth to its original point of projection. Assuming that the acceleration is the gravity is 9.81 meter per second. Okay, find the maximum height reached, the time taken to reach the maximum height, and the final velocity at the point of the projection. Okay, so for A, number 1, or for number 1, A, using V square equals to U square plus 2 AS or GH, right? AS and GH is interchangeable. Okay, so V equals to 0 at the maximum height. Okay, what is happened is object is projected up and then goes up at the maximum height over here. This is maximum height, and then falls down back to the same place. It's just up and down like that. Okay, V equals to 0. So 0 equals to 20.0 squared plus 2 negative 9.81 times h. Why is negative 9.81? Because we assume that pointing up for vector is positive, pointing down vector is negative. So G is pointing down, right? So that's why we have negative 9.81. Okay. Now 19.62h, okay, equals to 400. So h is 20.4 meter. So it was the height of the flight maximum reach is 20.4 meter. So again, you see that V equals to 0 because at the maximum here V equals to 0, right? It must stop at V equals 0 and then it goes drop down the object. Okay, number 2, the time taken to reach the maximum height. So using V equals to U plus GT or AT, right? 0 equals to 20.0 plus negative 9.81 times t. So 9.81 t equals to 20.0. So t equals to 2.04 seconds. So that is the time to goes up. Okay, to goes up to its maximum height, 2.04 seconds. Okay, so number 3, the total time of the flight. So the total time is going up and goes down. Okay, so C or number 3, so using H equals to UT plus 1 over 2 GT squared. Okay, so since total change is displacement is 0, we have, so remember at this point, if you count both of the point over here, I take another color, both of the point, the initial position and the final position, it has a 0 change of displacement, 0 change of displacement, right? So 0 equals to 20.0 times t plus 1 over 2 negative 9.81 times t squared. Okay, so 0 equals to t 20.0 minus 4.905 t. Okay, and because it's a quadratic letter, so you have a roots of t equals to 0 second, of course at the point t equals to 0 second, or t equals to 4.08 second. So this point, another point is 4.08 second. And lastly, the final velocity at the point of projection. What is the v when it goes down? So using number 4, v equals to u plus gt for the whole flight. So v equals to 2.0, 20.0 plus negative 9.81 times 4.08. Okay, so v equals to negative 20.02. That is meter per second. So the final velocity is 20.02. Why is negative? Because we already say that point going down is negative. Okay, so moving downwards with 20.02 meter per second. So that is the example for the constant acceleration. Okay, so going to give some of the exercise in the WhatsApp, and see you again in Tuesday. Bye bye.